This is Radhika. I am going to discuss about the power electronics devices. It is for 5th sem electrical students. This is the elective subject. So in last classes we discussed about the power electronics devices that are almost 15 devices. We discussed devices and VI characteristics and GTO SCR ratings of the voltage and current rating. Actually, once again, we can repeat. I'm repeating again. Actually, what is the power electronics devices? Just for a few minutes. So, actually, what is the concept of power electronics? So here, so in this, actually, power electronics belongs partly to power engineers and partly to electronics engineers, which deals with an efficient conversion and flexible control of electrical power for various applications. So, a special type of power semiconductor devices are used for this purpose. A special type of power semiconductor devices are used for this purpose. Nowadays, the need of conversion means conservation of energy has made it mandatory so that the energy in all the systems be utilized efficiently. Power electronic systems offers the most cost effective mean of achieving this goal. Actually, these power electronics devices will be started in 1950s. Actually, 1950s are used in vacuum tubes. In place of vacuum tubes, they introduced semiconductor devices in 1950s. After 1950s, in 1960s, in place of semiconducting devices, they introduced BJT, bipolar junction transistors. After that, in 1970s, they introduced the MOSFET in place of BJT. In 1980s, they can introduce the SCR in place of MOSFET. So SCR means nothing but it is the silicon controlled rectifier. It is a semiconductor device. Each and every thyristor family, it has the four layers NPN and three terminals anode, cathode and gate. So in 1992, the MOS control thyristor MCT was introduced. So using of power electronics devices, actually the power electronics deals with conversion or control of electric power by wave shaping of the voltage, current or both using fast switching power semiconductor devices. Actually, this what are we are discussing about the power electronics devices? These are for only controlling and converting. Converting means it converts AC to DC, DC to AC or frequency converters. They are the conversion. In case of controlling, the some choppers like some devices will be used as a switch like on and off. So here the power semiconductor devices are used for controlling and conversion purpose. The control techniques require the switching on and switching off of these devices in general power electronic devices. So these power electronics devices will be used in more places. So these power electronic devices will be it are applicable in industries, residential, aerospace, commercial, transportation, telecommunication, utility system. For example, in case of industries, the arc and industrial furnaces, blowers and fans, pumps and compressors, industrial lasers, transformer tap changes, rolling mills, textile mills, cement mills and welding. So these are the normally industrial side. In case of residential, air conditioning cooking, lighting, space heating, refrigerators, electric door openers, dryers, fans, personal computers, other entertainment equipment, vacuum cleaners, washing and sewing machines, light dimmers, food mixers, food warners, and trays. So these are the normally residential applications of power electronics devices. Next, go for aerospaces. In aerospaces also, it will be used in space shuttle power suppliers, in satellite power suppliers, and aircraft power systems. So these are the applications for power electronics devices in aerospace. In case of commercial, the power electronics devices will be used in advertising, heating, air conditioning, central refrigeration, computers and office equipments, uninterruptible power suppliers means UPS, elevators, light dimmers, and flashers. So these are the SCR power electronics devices applications in commercial. In case of transportation, the devices will be used in battery charges, traction control of electric vehicles, electric locomotives, street cars, trolley buses, and subways, automotive electrons. So these are application for um, power electronic devices in transportation, and also in telecommunication they are used in battery chargers, power suppliers, means in DC and UPS. And also these devices are used in utility systems. So that are high voltage DC transmission, excitation systems, VR compensation, static circuit breakers, fans, and boilers, feed pumps, supplementary energy systems, means solar and wind. So these are the power electronics devices applications in utility systems. So this is the basic concept of some power electronics devices. Now, actually today we are going to discuss about the diag. But before going to that one, in last class we discussed about the G2O SCR. So some it has the some few topics in GTO-SCR. In GTO-SCR, so it has the few topics of GTO-SCR, and the GTO-SCR actually GTO-SCR is same like SCR, but the SCR will works in only forward bias, and GTO-SCR will be worked in forward and reverse bias. In this GTO-SCR, when the positive signal is applied, a GTO switches into conduction state like an ordinary SCR. In ordinary thyristor, the current gains of two transistors NPN and PNP are very high, so that the gate sensitivity for turn on the thyristor is high, and hence the on state voltage drop is low. So here in GTO-SCR, the current gain of PNP transistor is low, so that turn off is possible if sufficient current is drawn from the gate. When a negative gate signal is applied, the excess carriers are drawn from the base region of PNP or NPN transistor, and the collector current of PNP transistor is diverted to the gate. Thus, the base drive of NPN transistor is removed, and this in turn removes the base drive of PNP transistor, and turn off is achieved. Actually, in a structure of GTO, the reduction in gain of the PNP transistor may be obtained by introduction of anode to N-base short circuiting spots. So this short circuited anode emitter structure has a low on-state voltage, but the ability to block the reverse voltage is poor. Large GTOs further have an interdigited gate cathode structure in which the cathode emitter consists of many parallel connected N-type fingers diffused into the P-type gate region. This type of structure provides a simultaneous turn on or turn off of the whole active area of the chip. So, compared to SCR, the GTO SCR is it is the more reliable. It has the high efficiency. It has the fast switching speed. No need of commutation circuit to turn off, and more di by dt ratings at turn on, and it has the high efficiency because of elimination of commutation losses. For the same rating, size and weight of GTO circuit is smaller and less noise due to elimination of commutation circuit. Higher gates current required due to multi-cathode structures of GTO, higher values of latching and holding currents, higher gate circuit losses, lower reverse voltage blocking capacity. So these are the few points about the GTO SCR. So now I am going to discuss about the operation of diac. Diac means it is the diode that can work on AC, means alternating current. The diode, it can work on the alternating current. So now we are going to discuss about the operating. So operation of diac, cross-sectional view of diac, VA characteristics of diac, and applications of diac. So these are the 4 points we are going to discuss about the diac. So actually diac means it works on, the diode works on AC, alternating current, and also it has the bidirectional thyristor diode, means diac. Bidirectional thyristor diode means diac. So in diac, the word DIAC is obtained from capital letters. Diode that can work on AC, alternating current. It is a two-terminal electrode device which can conduct in either direction. Hence, it is called bidirectional device. So the diac is work in two directions, from cathode to anode, anode to cathode. So in diac, it has the only two terminal. It is gateless. It has no gate. In triode, in triac, it has the gate T1, T2, and gate terminal. But in diac, it has no gate terminal, and it has the only terminals, two terminals, T1 and T2. So here T1 means VT1, terminal voltage of T1, and V2 is the terminal voltage of T2. So construction of diac. So the word diac is obtained from capital letters. Diode can work on AC, means alternating current. It is a two-terminal electrode device which can conduct in either direction. Hence, it is called bidirectional device. So it is called bidirectional device. So in this, it has the PN, and in diagram, just you can observe, here is the PN, and in right side N dash PN. So here in it shows the cross sectional view of a diag. It consists of 4 layers, PN and PN dash, and has two terminals T1 and T2. So these terminals T1 and T2 are connected to P region of silicon separated by N region. The symbol of diac is shown in next figure. So about these symbols we discussed in last class, and in this diagram it has the PNPN and N dash PNP. So here it consists of 4 layers and 2 terminals. PNPN layers will conduct uh, so here in this it consists of 4 layers and 2 terminals. PN layers will conduct during forward bias, and NPN dash layers will conduct during reverse bias, forward bias and reverse bias. So the actually what is the operation of diac? So it can work on alternating current. So it can works in only alternating current. It is bidirectional device. So it is the bidirectional device. So here in this, when the terminal T1 is positive with respect to mean, just you can observe in this diagram, when the terminal T1 is positive with respect to T2, the layers PN start conducting when the voltage of T1 is more than breakover voltage VBO1, and once the conduction starts, the current through the diac becomes very large and is limited by the internal resistance in the circuit. When the terminal T1 is positive with respect to T2, the layers PN start conducting when the voltage is T1 is more than breakover voltage VBO1. Once the conduction starts, the current through the diac becomes very large and is limited by the external resistance in the circuit. When the terminal T2 is positive with respect to T1, the layers PN dash starts conducting when the voltage of T2 is more than breakover voltage VBO2. So it will be we can again we will discuss when we are discussing VI characteristics of diac. So here in both cases the currents during blocking regions are very small and are called as leakage currents. The behavior in both directions are similar because doping level is same in all the layers, means PN and N dash PN. So the behavior in both directions are similar because doping level is same in all the layers into two directions, means forward and reverse. Forward is here it is the forward, NPN is the forward, N dash is the reverse. Generally, the breakover voltage of diac is about 30 to 50 volts, and voltage drop is across the device is about 3 to 5 volts. As compared to triac, the operating characteristics of diac is similar, but it has no gate terminal. Hence, it is also called as gateless triac. In triac, it has the another terminal gate, and the diac is called as gateless triac, and it has the few applications. So it consists of 4 layers and 2 terminals. PN layers will conduct during forward bias, and PN dash layers will conduct during reverse bias. So in operation of diac, diode it can works on AC. It can work on alternating current only. It is a bidirectional device, means it works anode to cathode like cathode to anode. It means T1 to terminal 1 to T2 and T2 to T1. So here VT1 means it is the terminal voltage of T1 is always greater than VBO1. VBO1 means it is the breakover voltage at terminal 1. means PN conducts in forward bias. Same as in reverse bias, the VT2 means terminal voltage at T2 is always greater than VBO2, means breakover voltage at terminal 2. That means at PN dash means downwards to upward conducts in reverse bias. Both the cases, current in the blocking region is small. So next we go for VI characteristics of diac. So here in this VI characteristics, VI characteristics, this diagram shows the VI characteristics of diac during forward bias. During forward bias means in first quadrant. During in forward bias means in first quadrant, the terminal T1 is positive with respect to T2, and if the voltage applied is less than VBO1, causes a small leakage current flows through the device. So in this, during forward bias, the terminal T1 is positive with respect to T2, and if the voltage applied is less than VBO1, causes a small leakage current flows through the device. When the voltage exceeds VBO1, it starts conducting, and current becomes very large. As the current increases, the voltage drop across diac decreases. Hence, it exhibits negative resistance characteristics. The characteristics are lies in the first quadrant only. When the voltage exceeds VBO1, it starts conducting, the current becomes very large. So it works as same SCR in first quadrant. As the current increases, the voltage drop across diac decreases. Hence, it exhibits negative resistance characteristics. The characteristics are lies in the first quadrant. So, next in third quadrant, it is the negative half cycle, means it is the reverse bias. During reverse bias, the terminal T2 is positive with respect to T2, and if the applied voltage is less than VBO2, causes a small leakage current flows through the device. When the voltage exceeds VBO2, it starts conducting. The characteristics are very similar to forward bias operations, but reverse bias characteristics lies in the third quadrant as shown in the figure. So here during the reverse bias, so this is the total characteristics. In case of during reverse bias, the terminal T2 is positive with respect to T1, and if the applied voltage is less than VBO2, causes a small leakage current flows through the device. When the voltage exceeds VBO2, it starts conducting. The characteristics are very similar to forward bias operations, but reverse bias characteristics lies in the third quadrant as shown in the third quadrant. Hence, from the above and from the these characteristics, it is observed that the diac during non-conducting period acts like an open switch and offers high resistance. So, when the diac is not conducting, that time it works as a like open switch, and it offers high resistance. So these are the means in first quadrant the diac works in forward directions, and in third quarter the diac will works in reverse bias. So here In this in these characteristics, its breakover voltage is lies between 30 to 50 volts. When conducting, it acts like a low resistance about 3 volts across it, and when not conducting, it acts like a open switch. And a diac, sometimes called as gateless triac, means the triac has the three terminals: terminal 1, terminal 2, and gate. The track will discuss in next class, but the diac has the gateless triac. So these diac applications are mean the diac will be used in it is triggering devices for track, in triggering devices, in light dimming circuits, and heat controlling circuits, and universal motors to control the speed. And about this diac, we can watch the YouTube video for more information. So here
Electronics lecture series. In this session, I'll be going to explain diac, and these are my session outlines where I'll explain first what is the meaning of diac, use of diac, symbol of diac, then we'll see structure of diac, and then at the end we'll come summing up the session with characteristic of diac. So first is what is the meaning of diac. So when we talk about meaning of diac, diac means diode alternating current. It is diode alternating current. So this is what the basic meaning of that, where one can clearly see di, these two letters, that is what we are taking it for, first two letter, and then a, and then c, that results into diac, that is having meaning which is what, diode alternating current. Now second is what, use of diac. So diac, that is widely used in AC circuit along with triac. So that is what we are using it to trigger triac. So diac, it is used in AC circuit along with triac, and usually we use diac to trigger triac. Now let us have a basic symbol of diac. So basic symbol of diac, that is this. This is MT1 and this is MT2. So this is bidirectional device, and one can clearly see from symbol even. So even if you connect MT2 positive with respect to MT1, or MT1 is positive with respect to MT2, because of it is bidirectional, functioning in both of the direction will be same. And next is what is the structure of diac. So here one can clearly see basic structure of diac, that is having two terminals, MT1 and MT2, and MT1 that is connected with N1 and P1 layer, and then there is a junction, and then again MT2 that is connected with P2 and N3 layer. So that is how multiple layers are there with this diac, and based on biasing of MT1 and MT2 terminal, layers are getting activated and its functioning is there. So let us have first case where MT1 that is positive with respect to MT2. So MT1 is positive with respect to MT2. So here one can say MT1 is positive with respect to MT2. So in this case, because of MT1 is positive with respect to MT2, this P1 layer that will be activated, and then there will be a sequence N2 P2, and this is what negative with respect to MT1. So here N3 layer, that is how the sequence will be there. So ultimately direction of current, that will be in this direction, as this junction will be forward bias junction, this is reverse bias junction, and this is forward bias junction. So its functioning is similar to SCR's forward bias characteristic, and after having a breakdown of this junction, N2P2 junction, there will be a flow of current. So current direction will be this, from MT1 to MT2 after having a breakdown of N2P2 junction, and this is what the case which is there with MT1 is positive with respect to MT2. Now let us have a second case where I am just considering MT2 is positive with respect to MT1. So MT2 is positive, so now layer activation, that will be there with respect to P2. So now this layer will get activated. The reason is MT2 is positive, so one can say here there will be P2 layer activated, N2, P1 and N1. Here N1 is there. The reason is MT2 is positive with respect to MT1, so MT1 will be negative with respect to MT2. So in this case one can clearly see this junction will be in forward bias, this will be in reverse bias, and this will be in forward bias. So direction of current, that will be in this direction, direction of current, that will be in this direction after having a breakdown of N2P1 junction. So its characteristic is even similar to SCR's forward bias characteristic, but that is what with opposite direction current with respect to MT1 positive with respect to MT2. So direction of current in MT1 of positive with respect to MT2 and MT2 positive with respect to MT1, both are completely opposite but functioning is same, and both having same characteristic as it is there in SCR's forward bias characteristic. But the difference is there is no gate control which is there with DIAC, while that possibility was there with SCR. So let us have a characteristic. So here we have considered first case, MT1 is positive with respect to MT2. So in this case initially there will be no flow of current, and that is happening because of P2 N2 junction is in reverse bias, and once that junction is having breakdown, there will be a flow of current as we have observed it in SCR's characteristic, and that is how its functioning is there. And direction of current, that is in this direction, which one can see it is in this direction, which we have considered to be positive. And second case, that is MT2 is positive with respect to MT1. In that case P1 N2 junction, that is in reverse bias, so because of that junction is in reverse bias, there will be very minor current will flow, and once that P1 N2 junction breakdown is happening, there will be a flow of current and characteristic that one can clearly observe. So here this case is MT2 is positive with respect to MT1. So this is how characteristic of DIAC is there. So ultimately DIAC is a bidirectional device, but there is no gate control. So we don't have any control over DIAC functioning, but all one can say is once it is getting triggered, there will be a flow of current from MT1 to MT2 and MT2 to MT1. Thank you so much for watching this video, and if you have any query, just place comments in that description, or you just write down your questions here so that we can have a discussion and we can sort out those problems. Thank you so much for watching this video. To Power Electronics lecture series. Here in this session I'll be going to discuss about triac, and these are my session outlines, where first I'll explain what is the meaning of triac, then we'll see some uses of triac, then we'll observe symbol of triac, then I'll explain triac equivalent circuit, Then we'll see characteristic of track, and at the end we'll conclude this session with applications of track. So let us begin this session.
So here we watched the YouTube lesson for DIAC, and and also again I'm just briefly explain about the DIAC. Actually, the word DIAC is obtained from capital letters DIAC. DIAC means diode that can work on AC, means alternating current. It is a two-terminal, means two electrodes device which can conduct in either direction. Hence, it is called bidirectional device. So here, in this, uh, the cross-sectional view of diac, it consists of four layers, NPN and PN dash, and it has the two terminals T1 and T2. These terminals T1 and T2 are connected P region of silicon separated by N region, and the symbol of diac. Already we have seen the symbol of diac, and when the terminal T1 is positive with respect to T2, the layers PN start conducting. When the voltage of T1 is more than breakover voltage VBO1, once the conduction starts, the current through the diac becomes very large and is limited by the external resistance in the circuit. When the terminal T2 is positive with respect to T1, the layers PN dash starts conducting. When the voltage of T2 is more than the breakover voltage VBO2, and in both cases the currents during blocking regions are very small and are called as leakage currents. The behavior in both directions are similar because the doping level is same in all the layers in two directions. Generally, the breakover voltage of DIAC is 30 to 50 volts, and the voltage drop is across the device is about 3 to 5 volts. So here, as compared to track, the operational characteristics of DAC is similar, but it has no gate terminal. Hence, it is called as gateless track. So, in this, today in class we discussed about the construction of DIAC, operating mode of DIAC, and VA characteristics of DIAC and applications of DIAC. And also here we have the few quiz questions, and we have the frequently asked questions. So this is the today's class about the DAC, and in next class we are going to discuss about the track. Thank you.